Well, hey everybody, Mr. Reeves back with you, and today we're going to be looking at solving percent problems. So we have spent a couple lessons on understanding and representing percents, and now we're going to be solving some problems involving percents. So we are in lesson 8.3 of the 6th grade math book. So they give us this problem. It says the sports store received a shipment of 400 baseball gloves. 30% were left-handed. How many left-handed gloves were in the shipment? So the entire shipment is 400. 30% were left-handed. So as we solve these problems, we're going to be comparing two sets of ratios, or two pairs of ratios, or actually one pair of ratio if I think about it, right? One of those ratios is going to be a percent ratio, and the other ratio is going to be the quantity ratio. So if we look here, we have 30%. Whoops, let's get this full screen here. We have 30%. That gives us our percent ratio. 30%, as we have said just a few times, is equivalent to 30 over 100 because percent literally means per 100, right? So they have this nice little diagram here. So you could see it's 30 per 100, right? So that again is our percent ratio. But then we also know we have a quantity of 400 baseball gloves. So we know that for every 100 baseball gloves, 30 are left-handed. Okay, so we have left and we have total. So we know that for every 100, 30 are left-handed. And we know we have a total of 400, right? So the question is, how many do we need out of that total of 400 that would be equivalent? Do you remember that word equivalent? Equivalent means it's equal in value, even though it looks different, equal in value. How many do we need out of the entire shipment to equal 30 out of 100? So they have this kind of cool diagram here that I really like. They have 30 over 100, then they have 30 over 100. Okay, and then we're going to go ahead and we need a total of 400. So there's 100, there's 200, right? We're going to need two more of these. All right, and I'm going to freehand this, so I'm going to apologize ahead of time. It's not going to look so great. All right, but I'll do my best here. All right, so that would be a 30 out of 100. All right, and that would be a 30 out of 100 right here. All right, yes, that is a 30. All right, I apologize. Let me make that a little bit better. Here, I'll put the number first, and then I'll make the rectangle around it. How's that? Not much better. Okay, so can you see now we have a total of 400, right? 100, 200, 300, 400, right? So what did we need? We needed 4 of those 100s to get up to our total of 400. But if these truly are going to be equivalent, whatever we multiply by on the bottom, we're going to multiply on the top. Do you see how we also have 4 of those 30s, right? 30, 60, 90, and 120. So that missing number we needed right here was 120. So 30%, 30 out of 100 is equivalent to 120 out of 400. So let's go back and fill in some of this. 30% means 30 out of 100. All right, there were 30 left-handed gloves for every 100 baseball gloves. All right, so there were 30 times 4, or 120 left-handed baseball gloves in the shipment. So our entire focus today is going to be about completing these proportional relationships. All right, All right, I'm going to be calling this number right here the equivalency factor. That's what we're going to have to multiply by to get from the smaller values in the one ratio to the larger in the other. All right, many times we're going to be going from the quantity to the percent, but sometimes we're going to be going from the percent to the quantity. Our goal is to create this true proportion. All right, and we're going to be talking about the part over the whole equals the part over the whole. And one of those ratios is going to be the percent ratio, and the other ratio is going to be the quantity ratio. Or again, percent, that whole will always be 100 because percent is always out of 100, okay? For quantity, those will change on a regular basis. In this case, all right, our percent was 30 over 100, right? That was our part. So our part on our percent was 30, and our whole was 100 because for the percent, the whole will always be 100. Our entire quantity, our total quantity, our whole quantity was 400, right? And so our equivalency factor was 4. So we're going to be doing a lot of that type of thing. And real quick, you might come across these bar models. I just want you to see, all right, we have the same kind of idea. We have percent on the top, and we have quantity on the bottom. And you could see they've broken up that percent into 10%, right? So 100% divided by 10 is 10%. So each line on the top is 10%. 400 divided by 10 is 40. So each piece on the bottom is 40. So we'd go 80, then we'd go 120, 160, 200. You can see we're at 50%. Half of 200 is 400, right? And then we have 240, 280, 320, 360, and 400, right? And you could see this was our answer right here. We wanted 30%, and 30% was 120. And each one of these creates its own little equivalent proportion, right? So 10 over 100, that's 10%, right, would equal 40 over 400. There's one of those proportions we're talking about. Over this one right here, 60 over 100 equals 240 over 400, right? Or if I did this one, 90 over 100 equals 360 over 400. So these are those proportions that we're going to be writing, proportions like this. And what's going to happen is we're going to know 3 of the 4 parts, and we're going to have to find that missing part. Again, this is percent. This is quantity, okay? This is percent. This is quantity. This is percent. This is quantity. All right, so that's our introduction to solving percent problems. In our next video, we're going to actually dive in and do some solving. Hope this one helped. Till next time, bye.